Okay, so today we are going to talk about numerical solutions. Before starting off with the new topics, I would like to give you a quick recap. Okay, so till now we have discussed how to find roots. I mean, we have been discussing that since O levels, you know how to find roots, we know that. But here, the question is that how to know if the root would exist or not. Okay, so be clear with this chapter has more to do with knowing the existence of root than finding it. Okay, so I'll give you a recap by discussing an example. Let's say that you have been asked to show that sine of x equals 0 has a root in the interval pi by 2 x 3 pi by 2. So basically x is greater than pi by 2 and it is less than 3 pi by 2. Before doing any working, let's just discuss the graph of sine just so we can get a better idea of what exactly we are talking about. Okay, so this is sine x and this is x, and it is basically this is the graph. So this is pi by 2, this is pi, and this is 3 pi by 2. I'm only mentioning these x coordinates because of my interval, right? And this is 1 and this is -1. Okay, so sine of x at x equals pi by 2 is 1, and sine of x at x equals 3 pi by 2 is -1. Okay, so what was the method? The method was to find the value of function. What is the function? The function is sine x. Sine x is the function, and you need to find the value of function at the end points of your interval. Okay, so you need to find the value of function at pi by 2. Sine pi by 2 is 1. We can see that from our graph. And sine 3 pi by 2, I'm sorry, it's 2.
Negative
Sine,
1.
very good. 3 pi by 2 is -1. Excellent. Okay. So, okay. Now this is a positive value and this is a negative value. The thing which we need to realize in this chapter is that if we have a function, let's say sine, and at this value of x, at the first value of our interval, the function is positive, it is 1. And at the ending of the interval or at the other limit of the interval, it is negative. So this means our graph is going from positive value of y to negative value of y. Okay. Now, what does it imply? Obviously, our graph is going from here to here. So it would definitely cross the x-axis to do that. Till now, we are saying that it would definitely cross the x-axis just because at this point we are getting a positive value and at this point we are getting a negative value. So that is only possible in case of a continuous function that our function passes through the x-axis as well. Okay, don't get confused with this word, the word continuous function. Okay, just ignore it. Till now, you should know that if there is a sign change between f of pi by 2 and f of 3 pi by 2. That is, if there is a sign change between the two values of function at these 2 points of as the at these two x's. Okay, this implies there is a root. So this is what we have discussed so far from the graph as well, and from this method as well. Whenever we have a sign change, it could have been we had negative here and positive here. All we are focusing at is sign change. All right. Other than this, we discussed some graphs of, quadratic functions, linear functions. We were good at it. So let's talk about another example from the same topic. Okay. So is it clear, Anjani?
Yes.
Okay. I will write down the question first. It is a bit long question. So, okay. Okay. Before discussing this, I would like to talk about the graphs of x cube, because we will be dealing with cubic functions today, and we will just talk about the two simplest cases. Okay, the two most simple cases. Okay, so are you familiar with the graphs of cubic function?
Yes, it's kind of like a wave.
Very good. Okay, that's perfect. But just for the sake of completeness, let's just do here as well. Okay, so this is y, this is x, this is y, this is x. Okay, so let's talk about the graph of y equals minus x cube here. Okay, so the graph goes like this. Okay, it's this sort of a graph. And for y equals x cube, and all you need to do is learn these graphs. Okay, it's basically passing through the origin and this as well. Okay, so these are the two graphs you should know till now, and then we are good to go with our example. Okay, so are you clear with these two graphs? Ranjani, are you clear with these graphs? I can't hear you. Are you clear with these graphs? Can you hear me? Okay, can you hear me now? I can't hear you.
Can you hear me now?
Yes, I can hear you now. So, yeah. Are you clear with these graphs?
Yes.
Okay, perfect. So let's talk about our example. Okay. So the example is on the same set of x's, sketch the graphs of y equals x cube and y equals x squared plus 2x for minus 3 less than x less than 3. Okay, so this is our question. So do you know how to plot the graph of y equals x squared plus 2x? Any idea? We have discussed this in last class.
Yes. 2x means it'll move up to x.
Okay, just look at it once again and then yes, okay?
Square
Okay,
plus
the hint
2x.
is that you will be using completing square method here.
Yes. Yeah, I remember.
All right, so okay, let's do it together then. Okay, so this is the first part, and then I'll do this part first, and then we'll talk about the second part. So let's just simplify this equation first, and then we'll move on to the plotting of graphs. Okay, let's just do the simplification on this side. Okay, so we have y equals x square plus 2x, and we know that we have not discussed how to plot a quadratic curve with this equation. Okay, so we need to make things simpler for ourselves, and we will be converting it into the general form by completing the square. So it is a square plus 2ab plus I need b squared. If this is 2, if this is x, it means b is 1. So if I'm adding something in mathematics to keep things neutral, I need to subtract it as well. So this is basically x plus 1 whole square minus 1. Is it clear? Are you clear with the simplification?
Yes.
Perfect. Okay. Now let's just continue with the graph with the first part of our question. So let's just plot the graph for y equals x squared plus 2x first, and then we'll go to the cubic function. Let's use this color. So this is the graph. Okay. So if I had y equals x squared, my graph would have been like this. Since this is for x squared and here I have plus 1, so my graph would move towards the left side. Okay, and this is minus 1. So the x-axis would be somewhere here, but I need to see this as well. This is minus 1, so it would move 1 unit down. Okay. So I know that the stationary point of my parabola would be this one. And since it is positive here, so it is going to be a U-shaped curve. I know that. I'm clear with it. But the next question is I need to find the values of x where my graph would be crossing from x-axis. So basically, I need the roots, or basically, I need the values of x where y is 0, because at x-axis, y is 0. Are you clear with this part?
Yes.
Okay, perfect. So I will simply use this again because I personally think that y equals x squared plus 2x is easier to handle when we are finding x's. I will just take x common, so I'll be left with this. Now 0 equals this expression is this. This implies x equals 0 and
Or x equals -2.
excellent. Okay. So this is negative 2 and this is 0, right? We know that this is 0. Okay. Now I'm going to plot the graph. I know that my graph, this would be the stationary point or vertex. So it would pass through here like this and through this point as well. Okay. Yeah, like this. Okay. But this is my range. I need to be very, very careful with the range. And I will only be plotting that much area. Okay. So this is till x greater than minus, this is from x equals -3 and less than 3. Okay, this is the range. Okay, so I'm done with this graph. Let's talk about this graph now. Okay, y equals x cube. All right, so we have just discussed that graph of such an equation would be like, it would go on like this, and it would be of this type. Okay, so this is for y equals x cube, and this one is for y equals x squared plus 2x. So we are done with the first part. Are you clear with the first part?
Yes.
Okay. The second part says use your graph to show that the equation x cube equals x square plus 2x has 3 roots. Okay. Now, do you have any idea about this part?
You can equate both of the equations.
Mm-hmm. But they are saying that use your graph.
Oh, use your graph.
Okay. Now look, these are the two equations. X cube equals x square plus 2x. I mean, this is one equation, but you can see that we have something similar in the first part, okay? So if you think of these two equations as two simultaneous equations, and if you start solving them, we have y and y same, okay? So I can always write right hand side of equation 1 equals right hand side of equation 2, and this is what I'm going to get. So this equation basically refers to first part, right? And in first part, I can see that I have 3 points where both of these graphs are intersecting each other. So these are the 3 points, and this is basically telling us that we would have 3 roots by looking at the graph. Okay, I'll explain it to you again. Okay. So this is the second part. X cube equals x square plus 2x. We need to notice that in the first part, we have been given two equations. Now, these two equations are basically equivalent to this equation. How? Because here we have same left hand sides. If I think of these two equations as simultaneous equations and I start solving them, I would end up getting this type of equation. So if I'm getting this graph for these two equations, I would have gotten a similar type of graph for this as well, where it would have been, cutting the x-axis at 3 points. Not exactly of this type, but a graph of a nature which would be basically, which would have been cutting the x-axis at 3 points at the same 3 points. Okay. So if I do it this way or I do it this way, the beauty of maths is that it ends up same. Okay. So here, since this is the second part and you have been asked to use the first part, the only thing you have to notice is that this equation refers to these two equations basically. And 1, 2, 3, these are the 3 points where my two equations are cutting each other. So these are the 3 roots. Is it clear?
Yes.
Sure.
Yes.
Okay, so don't get into too much details. All you need to know is that yes, this equation is basically coming from these two. And if you are basically getting three intersecting points, 1, 2, 3, it implies that you will have 3 roots. Okay, this is the only thing you need to understand. Okay, all right. So, okay, and then we have a third part which says show that one root of equation x cube equals x square plus 2x lies in the interval 1.8 less than x 2.1. Okay. And I want you to help me with this part because we have been discussing this already. So how would you do this part?
You have to substitute 1.8 and 2.1 into the equation.
Okay, but would you be doing that directly in this equation or you would simplify it first? Because
Simplify it first
how am I going to simplify it?
by taking x common.
Okay, but why would I do it that way? I mean, the thing is that here this equation has both left hand side and right hand side. The things, the
And if we
question,
equate it to a 0, then it will be
exactly.
a
It would be a function then, okay?
cubic. Yeah.
Minus x square minus 2x equals 0. Now this thing is basically my function. I need to think of it as my function, okay? The rule where we used to say that f of a, let's say a is the initial limit, and f of b. If sign changes for both these, it implies there exists a root. So basically,
Root.
for function, in such an equation, this thing would be function. And for finding this thing, we need to make sure that it is equal to 0, okay? So let's do it. Let's just put 1.8 cubic minus 1.8 square minus 2 into 1.8. This is going to be minus 1.008. You can do it through calculator. And if I do it for 2.1, it would be 0.651. Okay, so Ranjani, how is it implying that there's a root?
So there is a change in sign. The first
Okay,
one is negative and the second is positive.
very good, excellent. Okay, so we are done with the first, and you have to write this line, okay? Never ever forget this. This is the justification which they want, okay? You would be able to see it in marking scheme as well. There is a sign change between f of 1.8 and f of 2.1. Therefore, there is a root of x square x cube equals x square plus 2x in this interval. Okay, so you have to write down this whole thing. You would not get marks for this part only. Okay, this is the justification. Okay, is it clear?
Yes.
Okay, perfect. All right, okay. Let's talk about some more graphs and then we'll move on to our next section. So let's talk about graphs. Y equals 1 by x squared. Do you know how to plot this graph?
Is it a reciprocal graph?
Yeah, it is a reciprocal basically.
It's in two corners. Like,
Yeah, excellent. Okay. It's really good that you know these basics, because you know these are very important for the basic concepts of maths. Okay. So I will just draw it because our question is based on this drawing. Okay. So the graph of 1 over x square is, I hope that I am able to draw it appropriately because I'm not that good at drawing. Okay, so if this is the y-axis, it would be it would almost be just, close to it, but it would never cut it. It would go along this, but it is not going to cut it, okay? On this side as well, and on this side as well. They would get very close, but it is not going to cut it. Cut the x-axis and y-axis, okay? This is an asymptotic graph. So this is for y equals 1 over x square. And if I talk about e to the x, again, things are very similar. It would be of this type. And what is this value? Hmm? What?
y, x, and y, right?
Yeah, what would be the value of y here? Just look at this and you can tell me easily.
Um,
So at this point, x is 0 because this is the y-axis. Uh, on y-axis, we have x equals 0. If I put x
one, one,
equals x, very good.
one.
Excellent. Okay. So this is basically, these are our two graphs. Are you clear with these?
Yes.
Okay, so this graph is basically, it gets very, very close to the x-axis and y-axis, but it never cuts it. It almost overlaps it, but it is not cutting it. Okay. All right. So let's talk about this question now. On the same pair of axes, sketch the graphs of y equals 1 by x square and y equals e to the x, where x is between -4 and 4. Okay. So we have just discussed these graphs. The only thing we have to do here is plot them on the same axis. So I'll use red color for y equals 1 by x square. This is for 1 by x square and 1 by x square, okay? And for this part, okay. So my question is that what would be the roots of 1 by x square equals e to the x? How many roots would we have for this equation? You can tell that easily by looking at the graph.
2 roots.
Why 2? This is what I
Because it's
wanted to discuss.
exactly, yeah,
It is only
at that
cutting
point,
at this point. It is not
but
cutting at this point, okay? It is overlapping. The definition of intersection says if two curves or lines are cutting each other at one point only, okay? If this is a line and I draw, okay, no, let me use a straight marker for this. If this is a line and if I draw a line parallel to it, just above it, this way. So do you think that the red line is cutting the green line at every point? No, it is not. Red and green lines are parallel here. Okay, so this is one of the most basic concepts of mathematics. When we say intersection, it means it should cut at one point only. I mean, it can cut at 2, 3, 4, 5, 6, 7, 8, 9, 10, 100,000 points, but it would not look like this. Okay, it is cutting continuously, it is not cutting, it is just overlapping. Okay, so this is what I wanted to tell you through this type of a graph. Both of these graphs are asymptotic. This is why it is overlapping over here. But you should know that intersection means if it is cutting like this. Are you clear with this?
yes,
Sure?
yes.
Okay, perfect. Okay, so let's just discuss our second unit. And it says, I think the meeting might end soon, but I'm not sure. Topic is how change of sign methods can fail. Okay, so this is the topic, and basically, I told you in our last class as well that this is a method, but it is not, you cannot apply it everywhere. We have discussed this already, okay? But here they are basically going to talk about it in a different way. So for this, I would directly start off with an example and you'll get a better idea. Just consider f of x equals 1 by x, okay? In the interval, this, okay, so this is the interval, x is between -1 and 1. And now just what if I ask you to tell me, Ranjani, would there be a root but in this interval? What are you going to do? You will simply do this, right?
Yes.
So this is negative, this is positive, and this implies that there's a sign change, so hence there is a root. Okay, this is what we know from 6.1. But for every question, for every situation, this is why we have introduced, what this is why they have introduced graphs as well. For every situation, you cannot just say blindly that yes, there would be a root or there would not be a root. This is why they have been discussing graphs as well, because you should know uh, their graphs as well. Okay, only then you would be able to know 100% that okay, if there would be a root or not, right? So let's talk about the graph of 1 by x. It is just like the graph of 1 by x square. Okay, like it is just a bit different. The quadrants are different, but the shape is same. So this is same, but since we have 1 by x, it's not x square. So for negative x's, y's would be negative as well, okay? This is what we have. And the graph is telling us that why are we getting negative here and positive here? Because if I look
It's a
at this,
reciprocal graph, so it's on
mhm,
either side. That's why one is positive and negative.
exactly, very good, excellent. And do you see the curve cutting the x-axis anywhere between
No, they
-1 and
are.
1? It isn't, right? It
No.
isn't cutting. So this is what they're saying. This is where the sign methods can fail. Okay, you need to know this thing, that where does this method fail. So are you clear with this example?
Yes.
Okay, so should I discuss the other example now?
Yes.
Okay, let's just talk about another example here. Example, okay, show that f of x is tan of x does not have a root in interval pi by 4, 3 pi by 4. Okay, so this is your question. Let's just talk about the solution now. So typically you would simply just start off by doing this. Okay, so tan at pi by 4,
1.
very good, and tan at 3 pi by 4 is
Negative
-1.
1.
Excellent. So typically it looks like that yes, there would be a root, but here we have to do further steps. We cannot just rely on this method because we know that this method fails as well, right? Okay. So, okay, let's just plot the graph of this function here. Okay, this is 0. This is pi by 4. This would be 1. Then this is pi by 2. And then we have a graph like this. So at 3 pi by 4, the value of function is -1. Okay? This, okay. So basically from pi by 4 to 3 pi by 4, the value of function is changing from positive to negative. But on the graph, we do not see any part of this blue curve cutting the orange curve between pi by 4 and 3 pi by 4. It is not cutting, okay? There's a space. So we can see that this method, the change of sign methods, is basically saying that yes, there would be a root. However, in reality, when we look into things by plotting them, we see that no, there's no root. So this is where our change of sign methods is failing. Okay, are you clear with it?
Yes.
100%?
Yes.
Okay, tell me honestly, because after this I will talk about the integration chapter.
No, it's fine.
Okay, perfect. So I clear the screen now. Okay, let me take out the questions I have to do today. Okay, before doing the questions, I would like to first discuss all the integration methods we have discussed so far. Okay, integration. Okay, all right. So how many methods have we discussed? I mean, what are the number of methods?
Integration by substitution, integration by parts,
Mm-hmm.
integration using partial fractions.
Very good. Okay. So let's just talk about some of the major types we should consider before solving any integration question. So I will do one, is the tan one. Then we have the f dash of x1. Then through partial fractions. Then we have substitution and by parts. Okay. So yeah. So basically we have discussed if we have a question of this nature, it would be 1 by a tan inverse x by a plus c. Okay. Now here I told you that obviously you are in A levels. They would not directly give you a question of this type that, okay, you have 1 over x square plus 2 square integrated. No, they are not going to do that. They are going to make things complicated for you by writing a 2 here, then they'll write x square, then they might write 49. I mean, this is still a very basic example, okay? First, you have to take this 2 out to make it look like this. You will have 1 in numerator, then you need to have x square plus a square.
7 square.
Yeah. So you need to make things look like the general form we have discussed in class. And I repeat, things would not be that easy, okay? You need to make them easy for yourself. So the biggest hint for this type of question is that in the numerator you will just have a constant number. It could be 2, 3, 4, 5, 10,000, any number, but it would be a constant number because you can always take constants out from your integral, but you can never take x out from your interval. Okay, you cannot do that. So be clear with us. Okay, are you clear with the first type?
Yes.
Okay, so this is type 1. Let's talk about type 2. I have basically named them by myself, okay? By myself, so don't think if you would not be able to find it anywhere else. Okay. Then what if you come across such an integration question
Ln of
where
f of x is c.
very good. ln of f of x plus c. Okay. Now here the question, the simplest example I can give you could be this. The derivative of denominator is in the numerator. But again, why would they give you something this simple, okay? They would make things very complicated for you. Now here I want you to tell me the basic difference in 1 and 2, that how would you be able to differentiate if it is this type 1 or type 2? What is the basic difference?
Type 1, there is no variable. In type 2, there is a variable.
Where? In the numerator or
In the
denominator?
numerator. In the
Excellent.
numerator.
Excellent. Okay. And the basic thing for both these is that it would be a fraction. Not necessarily for type 2. It could be that the question is in this form. So I mean apparently it is not a fraction, but you can always take this negative power to denominator. Okay. So be very clear with this. Right?
In this example, is it always necessary for the numerator to be a derivative of the denominator?
For which one?
In for type 2.
Okay. Now, obviously, it is not necessary that you get 2x directly. Necessary part is to have the variable, okay? If you have x cube plus, I mean, if you had x cube plus 1 in denominator, it's important to have x square in numerator. You can always make this 3 by multiplying and dividing, okay? You can play with constants, but x square was important. Here, if you had x, you would not have been able to do it this way, and this would have not have been the question as well. Obviously, they would give you questions which you are able to solve through methods and not by integration calculators, okay? Are you clear with the question?
Yes.
Sure. So variable is important, okay? And the exact variable. If you have x cube in denominator, you need x square in numerator because derivative of x cube is 3x square. If you have x square in denominator, you need x in numerator because x square would basically give you the derivative 2x, okay? All right. Let's talk about, oh, sorry. The third type. Okay, so the third type is where you have fractions, okay? You use partial fractions to split one fraction into multiple, and then use which type?
Either type 1 or type 2.
Okay, very good. Okay, yes, you can use type 1 and type 2 both, but you would not be able to use type 1. I appreciate that you responded, but why would you not be able to use type 1? Because in the denominator you would not get this type of, I mean, yes, definitely you will get, okay? But I told you in partial fractions, for such type of expressions, we have this. So if you have x here, you can do it through type 2, right?
Yes.
Do you understand this? I mean, you are correct that yes, we might get our big fraction with this type of a denominator, but when you are solving it through partial fractions, you will get bx plus c in numerator, and when you have x here, you cannot use type 1, you will use type 2. And why would you even use partial fractions for this type of question? You would not do it directly. It could be that the question is of this type and then you have to break it down into two fractions of this type, right?
Yes.
So are you clear with this now?
Yes.
Sure.
Yes.
Okay, perfect. This is the third type. Then we have discussed the fourth type, where we talk about the sub. No, let's not talk about the substitution method because I personally prefer integration by parts first, and I have told you that in the video as well. Integration by parts. Yes, okay. And what is the formula for integration by parts? I mean, we have been discussing that in previous classes as well. So what is the general formula which you have in your book? Okay, so basically it says if you have two functions, let's say the first function is u and the second function is dv by dx. Although it is not dv by dx, it is not the derivative, it's just the way they have written down the formula. First function would come as it is, you need to integrate the second function. Minus sign, you have this minus sign in integration. Then again, you have the integration of second function and derivative of first function. Okay, perfect. And here is our trick which we use for integration by parts. Okay, Ranjani, if you understand this table, this part of today's section, you will be able to do every integration question. Okay, so please let me know if you are not able to understand any part. Okay, so this is basically the trick we use to decide u. If we have x and we have sine x, we use x as u because algebra is coming first and trigonometry is coming after. So u is x, and then dv by dx would be sine x, right? Clear? Perfect. Okay. And let's just talk about the last type. It is the substitution method, where you substitute u equals something. Either you would be given or you would be doing it by yourself. Okay, so you use u equals something and then you have to do du by dx, and this is more of a hit and trial method. Okay, so you do du by dx and you see, by now you would be able to know if you are able to replace x completely or not. And your goal is not only to replace x but also to make question doable. And once you are done with it, you need to again substitute from u to x. And if you have a definite integral with limits, you need to change these limits according to u. Are you clear with it? Sure.
Yes.
Okay, perfect. So these are the only types we have discussed. All right, so let's do some questions now. Okay, I will write down the questions here and I'll do it in the next part, but I just want to have all this with me just so you are able to know. Okay, so let's say the first question is, you have been asked to integrate x over x square plus 4 dx. Okay, now this is the question And we have 5 methods, right? We have 5 methods. We only have these 5 methods, and we can, okay, and obviously there's a simple method, like if you have sine x, you know that integration of sine x is minus cos x. Okay, I have not included those things here. Okay, these are basically the methods we use for questions that you cannot do directly, for products, for quotients, for such questions. Okay, and this is what your book has as well. I have not missed anything, so don't worry about that. Okay, let's just think about the method we would be using for this question. So let's discuss the first type. In the first type, we have 1 over x squared plus a squared, where a is a constant. So obviously we have an x in the numerator, and we do not have any variable in this case. So type 1 cannot be used. Okay. Moving on to the type 2, it looks like maybe derivative of the second of the denominator is the numerator. But when we have a closer look at the denominator, we have this under root here. So certainly the derivative of this complicated function cannot be x. So we cannot use type 2 here. Okay. Type 3, here in the denominator, we have this type of function. We cannot break it down further into any partial fractions. I mean, if we do it, we would end up getting something of this form. So there's no use of, there's no point in applying partial fractions. Okay, clear with it as well? Okay, let's talk about integration by parts here. Now, if you think of it as two functions, let's say this is first function, and 1 by under root x squared plus 4 is the second function. Now, you can think of considering x as u and this as your second function. But when you will come to the integration of this part, because we know that we integrate this part, again, you would not be able to do how to integrate it. Or would you be able to? You would not be able to. Okay. I cannot hear you. Is it clear that why are we not able to apply the fourth method?
Yes.
Okay. So we are left with this method. Okay. And not because that we are left with this method, so this method to be applicable. We are not solving MCQs, but because if we use, and this is what we had in our question, but obviously in exam, it is very unlikely if that, I mean, they can tell you to use substitution method, but they would not tell you to use u equals x squared plus 4 or stuff like that. Okay, so in your book you had this help where they told you what to substitute. So if you use, okay, so we know that we will be doing it this method. Okay, we will discuss it after discussing the second question. I just want to discuss the types first, and then you are good to do it by yourself as well. Okay, I want to discuss the type of second question before time ends. Okay, the second question is integration 2x square minus 1 e to the minus x dx. This is the question. Now again, Ranjani, it is very obvious that, okay, I agree, you can take this e to the minus x to the denominator, okay? Never ever just think that it is not a fraction. Yes, you can definitely always write it like this as well. But now even if it is a fraction, you cannot use type 1, you cannot use type 2, right? You're clear with it?
Yes.
And you know, you cannot use type 3 as well. How would you make it simple? I mean, this fraction already is very simple, okay? So okay, so the remaining methods are integration by part and substitution method. And I told you, always prefer doing your questions through integration by parts, because when you think of it this way, you would be able to know orally that, okay, if I
Ma'am,
do
I
it.
can't hear you.
Can you hear me now? Can you hear me? Can you hear me now?
Yes, I can.
Okay. All right. So we are clear that first three methods are not applicable. I told you always prefer doing questions, always prefer applying the integration by parts method first. Okay. So if you have this question, You'll think in your mind orally. This is the algebraic part, this is the exponential part, so this would be u. Think of it as you and just imagine if you would be able to differentiate it. Yes, you would be able to. In the second attempt, you would be able to just get rid of this x. You'll only be left with e to the minus x, and then you know how to integrate e to the minus x. So
Yes.
you know that this would be done through integration by parts. Okay, let's just do it.
Minus e to the power minus x.
Okay, let me just write down the question. 2x square minus 1 e to the minus x dx. Now we are going to apply the integration by parts method here. So which is my first function? This is u and this is dv by dx. Okay, why is it u? Because it is an algebraic expression. This is exponential. Okay, so first function, that is u, comes as it is. I need to integrate the second function, and this is the integral minus sine integration. Sine comes, this thing comes again, minus e to the minus x, and derivative of this function is 4x. Are you clear till here?
Yes.
Minus minus plus integration 4x e to the minus x dx. I need to think of it now. Again, I will apply integration by parts. Okay, so this thing would come as it is, plus sign here. I will use curly brackets. I'll take 4x as first function. I'll integrate e to the minus x, minus sign, integration sign, minus e to the minus x again, and derivative. And now I'm only left with the exponential function. Okay, I don't have any other variable other than this, and I know how to integrate it. So this part would come as it is, minus e to the minus x, 4x, minus minus plus 4 would come outside, and the integral of e to the minus x is minus e to the x. Okay, plus c. So this is how you do integration. Are you clear with it?
Yes.
Okay, so we are done with the lecture. Let me just end the recording and then I'll help you.